Denisova cave in Siberia, Russia. Well, of course, Siberia is in Russia, has yielded a lot of archaeological material since it was first excavated in at least since 2010, more or less. We found that Neanderthals lived there. We found that our species, sapiens, lived there. And we also discovered that in that cave there was a third unknown hominin species that is a close cousin of ours, and he has been named Denisovans. The Denisovan people. Now they seem to have we sequenced their DNA. We see because there's just been enough fossils found to allow the sequencing of their DNA. We know that we can do that because the cave offers an extremely favorable preservation technique conditions, I should say, and we found a lot of material from Neanderthals and modern humans, but the Denisovan material is still very small. We know that there are a couple of teeth and a small phalange, a small bone, tip of a phalange, a finger, and then there's this bone, which I will talk about, and that's the bone fragment Denisova 11, which was found in 2012. Max Planck Institute in Leipzig, Germany, has just sequenced the DNA from that bone, and we found something very, very interesting. I've talked about this before, but since the Genome Project of the 90s, early 90s, where we sequenced sapiens DNA, we sequenced our DNA, and then sometime later, as we developed the technology to sequence them faster, I participated in the Genome Project while I was at university. I sent in my DNA, and I got it back. And in '92, when I did that, and since then we have completely sequenced the genome of Neanderthal as well, and we have found that our species interbred with Neanderthals, our other race of humans. Homo sapiens neanderthalensis mated with Homo sapiens sapiens. And I've said this, I've already done a few videos on it. It was not just one event. There was a sequence that the first sequence of mixing with Homo sapiens with Homo sapiens sapiens with Homo sapiens neanderthalensis happened around 200,000 years ago. And then there was a second mixing event around 100,000 year mark, more in the Central Asia, and then again around the 50,000 year mark in Western Europe. Now, we knew a lot about the western part of the Eurasian continent. We didn't know a lot about the eastern portion of the Eurasian continent, and up until now we had very little DNA material to extract the genomic sequence, the genomes from. And the Denisovan cave was one of the gold mines that we found. And so today was yesterday, not yesterday, 2 days ago, was released is the sequence of that it was obtained from Denisova 11, and I shall read it. Before that, let's share with everyone. Here it is. That bone came from a young girl around the 13-year-old mark. She was about 13 years old. And amazingly, anyway, after they extracted the DNA and sequenced it, they found that this individual had a Neanderthal mother and a Denisovan father. shall read. Up until 40,000 years ago, at least two groups of hominins inhabited Eurasia. Three, as we arrived earlier. Neanderthals in the west and Denisovans in the east. Generally correct, yes. Now, researchers at the Max Planck Institute of Evolutionary Anthropology in Leipzig, Germany, sequenced the genome of an ancient hominin individual from Siberia and discovered that she had a Neanderthal mother and a Denisovan father. We know it's a she because the genomes were XX chromosomes. So, together with their sister group, the Neanderthals, Denisovans are the closest extinct relatives of current living humans. We know from previous studies that Neanderthals and Denisovans must have occasionally had children together, Vivian Sloan said. Researchers at the Max Planck Institute of Evolutionary Anthropology, from now on I'm just going to say the Max Planck Institute, and one of three of the first authors of the study, but we never thought that we would be so lucky as to find the natural offspring of the two groups. We know that they must have interbred because we contain the evidence of that admixture. But this is the first time that they found the direct evidence of that admixture. The ancient individual is one represented by a single small bone fragment. The fragment is part of a large bone, a long bone, and we can estimate that this individual is at least 13 years old, said Ben Sviola of the Institute of Toronto. The bone fragment was found in 2012 at the Denisovan cave in Russia, of course, by Russian archaeologists. It was brought to Leipzig for genetic analysis after it was identified as a hominin bone based on the protein composition, mostly due to the keratin in the bone that they found out it was hominin based and not other animals. So, a picture of the bone itself. See how big it is. There's a scale, and below it is the valley view from Denisovan cave. Just a quick, see if I can bring it up. Here we go. Just a quick perspective on this. Why is this cave so valuable? As you can see, it's a valley. There is a river, which I have the link for to the press release from Max Planck Institute in my description. I also have a couple of mainstream journals that have published it, including the Daily Mail and another one, The Atlantic, I think it is. And they have much more better pictures. But just outside the cave itself, there is a stream passing by. So the people living in this place, during at least not in winter, would have had water supply. They would have had the valley that would have been rich with animals for them to hunt. So it was an extremely rich place to live. That's why it was occupied for so long, because it was just perfect. The valleys around this area would have been teeming with life, from megasauruses, big animals, I should say, to megafauna, to small animals, to lots of plants and other materials that they could use to eat, etc., and just primary and just resources to manufacture everything they needed. Back to the article. So an interesting aspect of this genome is that it allows us to learn things about two populations, the Neanderthals from the mother side and the Denisovans from the father side, explains Fabrizio Marfesani from the Max Planck Institute, who co-authored the study. The researchers determined that the mother was genetically closer to Neanderthals who lived in Western Europe than the Neanderthal individuals that lived early in the Denisovan cave. Like I said, in this cave, I've talked about this before, in this cave, there's a whole sequence of strata, archaeological sequences, which go back in time, of course, and there's Neanderthals up until us, modern humans, up until quite recently, in fact. So the DNA that they extracted from the previous other Neanderthals, from the Neanderthals that I excavated from Denisovan cave, the mother of this individual did not match those of the local population. So this shows that Neanderthals migrated between Western and Eastern Eurasia tens of thousands of years before before their disappearance. Yes, they were nomads, like we were nomads. They would have moved with the seasons, expanded territory, the contracted territories, depending on the conditions. So yes, they moved. It's normal. We were until the advent of agriculture, the Neolithic Revolution, when humans became more settled and more sedentary, we were nomads. So it's only natural. So the analysis of the genome also revealed that the Denisovan father had at least one Neanderthal ancestor further back in his family tree. So from this single genome, we were able to detect multiple instances of interactions between Neanderthals and Denisovan, says Benjamin Vermont of the Max Planck Institute, the third co-author of the study. It is striking that we find a Neanderthal Denisovan child among the handful of ancient individuals whose genomes have been sequenced, adds Svante Paabo, the director of the Max Planck Institute, and the lead author. Neanderthals and Denisovans may not have had many opportunities to meet, but when they did, they must have mated frequently, much more so than we previously thought, like we did with them. It's something that humans do, and they are humans. They are just a race of humans. I was reading some tweets discussing this, but with the Spanish archaeologist, which I really admire, Roberto Sanz, and also not Roberto Sanz. I apologize, with John Hawkes. He was tweeting about this, and someone asked him, "Yeah, but there's such a small sample. We can't generalize by such a small sample." True, we can't generalize, but he gave the analogy. It's like the first discovery of the exoplanets in astrophysics and astronomy. We found how to find them. Now we must find them, and after we found how to find them, the rest of the materials that the fossils, once they appear, we can now quickly find sequence them and gather more data. Direct data. This is direct data, not indirect data, which we mostly have in our genomes now. Modern humans have. I've said this before. Depending on the scale that's used, my percentage of Neanderthal is either 2.4, a maximum of 2.6, or 3.5 of a maximum of 4%. So I have quite a nice percentage of DNA of Neanderthal. That's about it. That ends it here. I'm just going to see what chat's going on about and say hello to everyone. How are you? Let's see. Hello, Tommy. Hello, Davey. Hello, Carlos David. Hello, Adam. How are you, man? How are you, my dude? Hello, John. How are you, my dear friends? Who else? Hello, Godiva. Pleasure to have you here today. Malefis, how are you? Who else? Okay, let's see. Some questions which I could answer. I'm going to do this because I can see it better. Let's see, Tommy. 40,000 years ago, it must have been a big meeting point there, since it was under the last ice age. Well, this place, no. Denisova Cave was not where this place is located. The ice sheets were not that covering it. The ice sheets are weird. They sort of, there are places where there are corridors. There are places where they're completely covered. For example, Paris 40,000 years ago was under a mile of ice. Yet there was a corridor in North America from Alaska to one of the many times that corridor appeared, by the way, down the west coast into the far there. Ice is weird, and especially the ice sheets there, they can develop and not. They're weird. They're not very logical. So yeah. How gay were the Neanderthals? I don't expect them to be very gay, but I don't know. We don't know. What else? We was Neanderthals and shit. Yes, Malahide, we was. Make Neanderthals great again. That could be a good catchphrase. Skin color. We don't know, but they would not be very dark, in fact. Darkness at the latitudes dark skin at the latitudes which Western Europe, Eurasia, is not very efficient. They would have been olivey skin, maybe. Further south, maybe olivey skin. Sort of like like me, basically. Or Northern Italians, or even Northern Greeks. So yeah, Homo erectus maximus eroticus. Oh, yep, that's our species. Homo sapiens, all three of them, were randy buggers. So yes. No, has nothing to do with the Siberian tribes. We can't compare our skin color to theirs. We know that the genes that they have for color are similar to ours, and there's evidence that they were redheads. They had red hair. So in association with the skin color genes that we know they are associated, there's talked about them. I think it's the FOX. I can't remember the numbers, and there's another one, which I also can't remember the name. The NOCT, NOCHT genes. They govern our skin color, eye color, and hair color. Every human has them. Some are switched on, giving you lighter, darker skin. Some are switched off, giving you lighter skin. So all humans have them. So they had them as well. They had it as well, and the genes that they seem to have had is, like I said, closer to what you would find Tibetans, for example. They sort of have a darkish type tinged because of their living in altitude, or not. I don't remember. I can't answer that until I get. I'll answer it, or I'll go back to my videos. I think I've answered it before anyway. Okay, serious question now. What ethnicity around they would they most resemble? Well, it's a different. It's not a different species, Adam. It's a different race of humans. So what would they? Well, let's have a look. They would be maybe Turkish. The Denisovans, Turkish to beginning Asians, and you know how, for example, Turkmenistan as Kyrgyzstan's, Western Tibet, Western China, Siberia. If you see them, the skin color now, you would they would have maybe have had that color. The Tibetans do carry the gene that allows them to live at high altitude that they have from the Denisovans. The Neanderthals don't carry that gene, so they maybe. But there's also two types of Denisovans. We've discovered there's the northern Denisovans and the southern Denisovans. The southern Denisovans mainly lived around Southeast Asia, Australasia, while the northern Denisovans lived around Denisovan Cave and possibly eastern Siberia. So possibly that So yeah, more features than skin color. They would have looked a lot like Neanderthals, of flats. This is speculation because we have not found the complete skeleton of them yet, but they did separate about between 500 to 400,000 years ago, Neanderthals and Denisovans. About the same time as we separated, more or less, developed as well in Africa from the same ancestor species, Heidelbergensis. But their hereditary went a different way. They maintained a flat forehead, sloping forehead, brow ridges, occipital bulb. That means the back of their head, their skull would have been protruding a little bit back. They may have been shorter stature and more muscular, barrel-chested type, like the Neanderthals were. So that's how they would have looked like. Adam, I hope that answers the question. What else? The biggest brain individual of all hominins was a Neanderthal that was discovered in Israel. He had a brain capacity of 1.7 liters, 1,775 cubic centimeters inside. Our average is 1,300 cc's, 1,380, 1,390. So I hope that also answers your question. My pleasure, Adam. I hope to have you one day and have a chat with you in a live stream about everything, you know what I mean. So, guys, I think I'll end it here. Hope you enjoyed it. I really love this. I really love this period of time and these hominins, our cousin species, because they are so fascinating. We are learning a lot more every day from new discoveries. And I made a prediction on answering that tweet about from John Hawkes that someone. Well, I answered him that this, like the needle in the hay analogy that he used, that will be the needle in a haystack. We will find more direct hybridization of the species. So thank you all for coming along. It's always an honor having you as in the chat, and good night.